Hello, class. Welcome to lesson number 3. We're still on rational functions. We'll try and conclude rational functions today. So we're going to start with an example, and just to make sure that everybody is on the same page, we're going to come up with a way to graph rational functions. Hopefully, the last video was helpful to give you some ideas on how to start this. But to sketch rational functions, I'm going to use an example that the textbook has so that we can kind of follow what they're trying to do. So the plan is simple. If you're given a rational function, if it's not in factored form, you want to get it in factored form. So that's the first thing. You want to factor the numerator and denominator. You can also find the intercept pretty easy. All right. Set x equal to 0 to find y intercept, and then set the numerator equal to 0 to find the x intercept. Then step number 3 is find the vertical asymptote. And you do that by setting the denominator equal to 0 and to check to see if y is going to positive or negative infinity as you approach that x from the left or the right. Okay. Step number 4, find the horizontal asymptote. So you find the horizontal asymptote by going through the 3 different ways of finding that line. That means you're looking at the degrees of the numerator and denominator, and we said if the degrees are equal, then you look at the coefficient of the leading term, and that becomes the equation of the horizontal asymptote. If the degree is less, so the degree of the numerator is less than the degree of the denominator, then the equation of the horizontal asymptote is going to be y equal to 0. And then the last case was if the degree of the numerator was bigger than the degree of the denominator, then you have no horizontal asymptote. So that is that, and then what you want to do is do a test case. Well, now you have all the ingredients, you know the direction and where everything is going. All you have to do is just use some test values to figure out are the curves going above or below the horizontal asymptote, and you also done your sign analysis to figure out which of the vertical asymptote you need to kind of pass through. Okay, so that's the plan. So let's look at the example that they have over here. So in the example 5, they factored out the expression, which came out nicely. There are no common factors, so we like this. And then they found the x-intercept, which was the half and -4. Found the y-intercept by plugging in 0 into the expression. They got that to be 2. And then vertical asymptote, based off of the factored form, if you look at the denominator, then the vertical asymptotes are going to be x equal to 1 and x equal to -2. And then look at the near behavior vertical asymptote. So you're trying to figure out, well, which is it, a positive or negative, as you get close to the vertical asymptotes. Now, you go through some test values, or better still, this is, if you look at where I am right now, 4 or 5, that is what we did last time. So I'm looking at, if you set this up and you go through, pick some test values as you approach each of the vertical asymptotes from the left or the right, you're able to analyze to find out what y is approaching. So in this case, they got negative infinity, positive infinity, negative infinity, positive infinity as you approach those vertical asymptotes. And then to find the horizontal asymptotes, they compare the leading, the degrees of the numerator and denominator were equal, so you just have to just find the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. In this case, it was 2. Therefore, the horizontal asymptote is y equal to 2. And then finally, you can do some test cases just to figure out in terms of, does the graph cross the horizontal asymptote or not? Or is it above or below? You do some test cases and then be able to sketch the whole graph. All right, and we can also draw our domain and range now that we have the graph we can look at the domain and then the range right from the graph over there. Okay, so this is just a recap of the video that I did last class so that you're able to do your homework. So now, this is where things get interesting. So I'm going to make another video just for this, okay?